Test, test. Everyone is ready? Hi. Good afternoon. Wake everybody up lunch. Wake everybody up after lunch. Thanks for coming. As you see by the title, I want to present IPv6 On Mikrotik. And my name is Hassan Asghari. I'm Mikrotik trainer. Also, I'm Ipv6 IPv6 trainer. I have over 10 years of experience on the networking, especially infrastructure fields. This is my this picture. This is my IPv6 training course from Ipv6, and bottom of the pictures are the trainer classes. You can write email for me if you have any question after this presentation. My email is hassan.asghari@hotmail.com. And here's our agenda. I have one slide for IPv4, why IPv4, and IPv4 exhaustion. Also, I have some slides about IPv4 strengths and weaknesses. At the duration of the presentation, I have two demos. First demo is IPv6 configuration on a router OS. And the second demo is configuring 64 tunneling on a Mikrotik using HE or Hurricane Electric Internet Services. I hope everyone here know what is the Hurricane Electronic, but don't worry, I want to talk at the next slide. Also, at the last of the presentation, I have a question and answer slides. So if you have any question, please write it on a piece of the paper and ask me at that time. So, why IPv4? I know everyone here are master of the IPv4, also master of the IPv6. So I ignore some basic IPv4 concepts, and everyone knows IPv4 is the most usable and popular protocol on the internet working. But out of the approximately 4 billion IPv4 addresses we have, but a little more than 1/8 of it cannot be used. Actually, those addresses have been reserved for special purposes, like documentation, private usage. For example, we have a RFC 980, and we have some reservation for special purpose and loopback, and some special purpose like documentation, or reserve for feature use will never come, actually. This leaves us with around 3 billion IP addresses to run a network on the public internet, and so continuing with IPv4 is not good to choice, because 3,675 billion users are connecting to the internet, and it is 50.1% of the people in the world. Actually, there are 7.4 billion people on the world, and some people have more than 3 devices connected to the internet, like me, 1, 2, and laptops. So, actually, the internet grows up, and we need more IP addresses to connect to the internet. We have a new technology, for example, IoT, and IoT devices must have IP addresses. Imagine in an IoT or Internet of Things, we have a refrigerator, lighting, cars, smart boards, and so on. And all of them needs IP addresses. So, what is the solution? Actually, we have we must to buy more IPv4 addresses, yeah? But if you pay attention for this slide, this is the statistics from INA. INA ran out of IPv4 on 3rd of February on 2011. And in a festival ceremony, they allocate last 88 to each RIRs. RIP NCC is one of the RIRs in the world, and it's received 105.000/8 allocation. So, unfortunately, the Internet of Things will not happening with IPv4. This means we only have 105/8 left, along with any recovered space the INA might get. This is called the last /8 pool. Actually, the last IPv4 pool. And every LIR can receive 1/22 IPv4 blocks for these networks. So, how much space do you have still? How long will it last? 1 year? 2 years? Maybe you say it depends. We have a problem in here. So, how can postpone this failure? How can postpone this problem? I know we have some solution, but the most popular is NAT. Yeah? I have a question for you. Who use NAT in their network? Who use? Probably most of them use NAT in our network, yeah? NAT is a network address translation. I know you know what is NAT, but NAT works like this. There's one stateful device, usually a router or DSL modems on our network with public IP addresses. And if the NAT router, and a client wants to visit internet, his source addresses is private. We call RFC 9080. Yeah. So we must have an IP public to change our source NAT, and this IP public must be routable on the internet. Actually, NAT do for us. It change our source IP addresses. It's a public address on the server and the private address on the background or RFC 980. Clients, if we have a NAT, clients can serve the internet, can visit the internet because they have public IP address. But what? Okay. But NAT have some problem. Actually, NAT breaks end-to-end connectivity. Imagine we have servers on the internet, for example, Google, and we have some clients on your network. If client wants to connect with Google servers, at the between the client and Google server, we have routers, and NAT breaks the direct connect from the client and servers. And actually, NAT does not allow connect with IPv4, so we have some solutions. I will speak on the next slide. And some people claim NAT is a security solutions. Yeah, imagine that we said we have a NAT on our network, and NAT takes some security for our network, because NAT prevent host counting on network. Yeah? But this security is not active security. This is a passive security. You must do active security with firewall. Okay. We can use NAT to postpone the IPv4 limitation, but it is not the permanently solution. So, what is how can we pass this failure permanently? So, the answer is IPv4. No, IPv6, yeah? Okay. The answer is IPv6. Actually, the successor of IPv4. So I want to talk about IPv6 Basics. Before talking about this, I prefer to know about how our IP address distributed. This is a IPv6 IP address distribution hierarchical model. I find the laser point. Excuse me. I'm so sorry. Okay. Excuse me. I can't. It's good. We are engineer. We can find way. Okay. If you see this, this is a hierarchical model to distributing IP from IAB. We have an IAB before INA, or Internet Architecture Board. IAB takes out SH3 for INA, or Internet Assigned Number Authority, and INA gives out /11 to each RIR. I hope everyone know there are 5 RIRs on the world. Their name is AFNIC, IRON, LACNIC, and RIPE-NCC. Actually, our country, Armenia, and our country, Iran, Turkey, and other country, sells IP from RIPE-NCC. If you have an ISP, you must have a LIR, or local internal registry, to receive IP from RIR. Okay. Let me. Thank you. Okay, it's good. So each RIR is responsible for some countries. If you want to know more about RIR, please Google it. At this hierarchical model, after INA we have RIR, and after RIR we have LIR, or INA I said Internet Authority Number Assigned, and we have RIR, or Regional Internal Registry, and before RIR we have LIR, or Local Internet Registry. Local Internet Registry means, for example, you have you work in ISP. Your ISP is LIR 2. In a real world, we have some personal people act like RIR. For example, me, I'm LIR 2. Okay, we have an end user at the bottom of the hierarchical model. End user means some organization, for example, telecommunication organization, ISP, or every organization, every person need IP addresses. The end users, if wanted to buy our IP, end user have two solutions to buy IP. The first solution is end users write a request to LIR. Okay, for example, I'm LIR. You wanted to have an IP address, by IP address, you write an email for me and request your IP pool to our network. In this scenario, I want give out you /48 or /56 IPv6 pool. But in this model, in these solutions, we have some problem. And the problem is, if end user wants to change our ISP or wants to change our service provider, it loses IP addresses. It's a big solution, big problem. So we have another solution. End user can buy our IP directly from RIR. We call PI. We call this action PI, provider independent. In this way, user buy IP, and also he must buy BGP numbers. If in this solution, if users want to change new ISP, its IP address is still remain and cannot be changed. Okay. Any question until now? So far, so good. IPv6 address basics. The most important advantage of the IPv6 over IPv4 is that IPv6 is 128 bits length protocol, and it's 4 times bigger than IPv4. Also, IPv4 is binary or base 2 numbering protocol, but IPv6 is hexadecimal numbering, or it's based on 16. So IPv6 support more IP as in comparison with legacy version, and this is the answer for my last question about IPv4 problem. In IPv6, we must send prefix to our clients. In IPv4, we run some provisioning mechanism, for example, DHCP, and DHCP servers send one IP for our clients. But in IPv6, we send /64 prefixes for our client. If you sum these IP addresses allocation, it's get 4 times bigger IPv4 addresses. Okay, I want to talk more about IPv6, but unfortunately, due to the lack of the time, I ignore this page, ignore this slide. This is the address notation in IPv6. I hope everyone here familiar with this address notation. This is a hexadecimal. Each group we call a quad or nibble. We call for each group of these nibble or quad. In IPv4 we called octet for this separation. We separate this nibble with colon, and it's easy. Clone, yeah, clone. But if you attention for this notation, it's a very long, and the memorizing of this is very hard for human. So we have two comparison method, two simplicity for this address notation. The first rule said you can omit leading zero. For example, if you attention this address, we have this zero, these two zeros, and these three zeros, and three zeros. This is and these two zeros too. This is a leading zero. Yeah? So we can omit it this like this. We can omit it this like this. Or we have one another rule and said you can omit it this continuous zero with dual colon. So if we see this notation, we can omit it this zero with one dual column. Okay. We have a multiple address types in IPv6. You know, we have some classes for IPv4, but in IPv6 we have some prefixes for IPv6. The first popular prefixes is unspecified prefixes. This is useful to initiation IPv6 client with other device, and it used for solicitation node addresses as a source address. We have a loopback addresses. What is the loopback addresses in IPv4? 127.0.0.1. Yeah. Yes. It's a loopback IP addresses. And this is the loopback addresses for IPv6. We have embedded prefixes for tunneling or transition mechanisms like NAT64. And this is the range of for transition mechanism or NAT64. 64 is a NAT64 IP addresses. We have a link local addresses. We have a link local prefixes. This is these IP addresses, these prefixes used in a local LAN. For example, if you have devices in your network and IPv6 enables on, we can see link local IP addresses on our NIC property. For example, maybe I show the link local addresses for you. It's here. If you see your property of the interface, you must have link local IP addresses. It's this. This is the loopback IP addresses. And where my cross? So now we know what is the link local addresses. Okay, it's done. We have a link global unicast addresses. This is the IP public for IPv6 world addresses. So this is this prefix is 2000::3, and as I said before, RIPE NCC gives 1/11/12 from this pool. We have a unique local addresses. The prefix is FC and FD, SH7. It's like RFC9 80 pool IP addresses, and at the bottom of the address list we have a multicast address range. These addresses used for solicitation addresses, and for example, we have some popular IPv6 solicitation address in IPv6. For example, FF02::1 and FF02::2 for all host addresses and all router addresses. Okay. Any question until so far? We have a first demo. The first demo is very easy. Everyone familiar with Mikrotik knows the Mikrotik routers is package-based routers, package-based software. So you must enable or you must install IPv6 package on your router. By default, IPv6 package is installed on the router OS, but it's not activated or it's not enabled. So you must active or enable this package on your router. It's very easy. You can go your router in a system package. You can find IPv6 package. Yes, this is by default. This package is disabled. So you must enable this. Then you must reboot your router to effect this change on your router. So after this action, we can IPv6 tabs appear in Winbox. You can see IPv6 tab here. In the other tab, you can see the link local IP addresses. Yeah? And link local IP addresses, flag is DL or dynamic and link local address. Okay? Okay. In these slides, I want to talk some IPv6 functionality, like SLAC or stateless address auto-configuration. As I said before, I ignored some basic concepts about IPv4 and IPv6, but I think this slide is useful, and I want to talk about this. In an IPv4 environment, when you connect your laptops or device to your network, in your network, if you have any DHCP server, you can get any IPv4 addresses. And this action must be configured but with our network administrative. But in an IPv6 environment, it is not important to configure some basically IPv6 on your router. For example, if you assign your IP addresses on your router, for example here, I want to assign one public IP address or global IP address like this. For example, this. We have two important, actually, this is /1001:/64 for example Ireland. We have two important options in here. The first is EUI64 checkbox. What is this? Actually, UI64 makes your IP address, IPv6 addresses on your based on 48 MAC addresses. But as I said before, the minimum prefix for client is 64, and in here we have 60. We need 16 more bits to configure these IP addresses. And here EI64 comes. EI64 adds 60 another bits to your IP addresses, IPv6 addresses, and complete the 128 bits IP address. For example, if I enable UI64 IP addresses and apply this, we get an randomly IP addresses here. This is based on UI64. After this, we have an advertise button or advertise checklist button. This checkbox useful to neighbor or enable discovery protocol. For example, I'm a device, my laptop or my cell phone. I connect this device to our network. The device at the first steps say hello for our neighbors. Yeah? And this packet based on a multicast. Okay? We say this packet names is solicitation node addresses. Yeah? And then clients want to give IP addresses from your routers. Clients generate some other packets. We call router solicitations and send to FF00::2. These addresses use for router solicitation. If any routers are available in our network, the routers answer this packet with router advertisement. In this packet, we have some very important options. For example, IPv6 prefixes, IPv6 DNS, or other options. So, this is done. I'm back to our presentation slides to continue our presentation. I talk about neighbor discovery, but you can Google it or you can inquiry our MTC IPv6 e-class to learn more about IPv6. We omit some IPv4 protocol in IPv6, like ARP. ARP used to mapping MAC addresses with IP addresses in layer 2, but in a IPv6 environment, we don't actually the ARP is replaced with ND or Neighbor Discovery Protocol. So I took this slide before. Imagine that you have laptops in an IPv6 network. You connect your laptops to the network. At the first step, client send neighbor solicitation, then receives neighbor advertisement. Then clients create link local IP addresses based IPv6 MAC addresses. And after that, clients send DAD packet to our network. DAD or duplicate address detection packets where client verified how can I say? Okay. client verified his IP addresses. It's unique with this packet or duplicate address detection. After that, if client needs routers or actually default gateway, he sends router solicitation. And if routers are available in our network, routers send router advertisement. And I said router advertisement packets have some important option like default gateway, like prefixes, and other important information. If you need, you can send with router advertisement to your client. Okay. Deploying IPv6. You can deploy IPv6 easily with EUI64 or auto configuration functionality on your network. It's very easy. I have one demo for this, but before demo, I want to talk about IPv6 address management. IPv6 address management is very easy, but if you are master of the IPv6. So I write some prefixes here, and I write some prefixes pool in for example, for /84, we have 64.536/64 prefixes, and it's very large number. You can manage this IP address with IPAM or IP address management. For example, you can Google it on a Google. And most popular use, I think, is PHP IPAM. It's free and you can download it. So we have a transition mechanism here. Actually, as I told before, we have some problems in an IPv4 and IPv6 environment network. For example, if you have IPv6 networks, you can communicate with IPv4 networks. Vice versa, if you have an IPv4 network, you can communicate directly with IPv6. So, we have some transition mechanism to solve this problem. For example, we have 6-to-4 mechanisms. In this mechanisms, you have an IPv4 networks, and you want to connect with IPv6 network. You can use this transition mechanism. But I think my time is done. So I ignore the concept of the concept about transition mechanisms and go to the demo. Our demo is about 6-to-4 transition mechanism. For this, you can you can Google it on the internet about tunnel broker. We call this action tunnel broker. But the most of the popular tunnel broker services is HE or Hurricane Electric. You can Google it and register in this website. Actually, this website freely gives out IPv6 prefix, and you can use these IPv6 prefixes in our network, in your network. So, for this, you must create regular tunnel. Okay. You must create regular tunnel. Here, you put your IPv4 network. It's your network, yeah. It's your network. You must have a public IP address on your router. For example, I have one router here, and this is the IP public for our router 93 blah blah. So I create this tunnel before. It's here. This is my tunnel. I set our IP addresses for HE, and in an example configuration, HE, you can create these tunnels manually, but HE websites gives you scripts to solve some basic commands problems. So in here I select our routers. Our router board is Mikrotik router OS is here, and this is a script. You can copy this script and paste it in your terminal, in your network, in your router. It's very easy. I do this before, so I have this tunnel here. I said your local addresses and remote address. This is the HE transmit router IP addresses. In here, we just create tunnel interfaces. Next step is you must assign IP addresses on your tunnel. So HE says your tunnel IP address here. It's here. I think server, here. Client IPv6 address. It's my site, and it's a HE site. So, if I'm right, this is my site. This is my site, okay? And the first one is for HE. Now, we just create IPv6 tunnel with HE and your networks. One step is required, and it is that you must create IPv6 default route to your service provider. So, for this, I go to IPv6 routes, and here I have some routes to the default gateway. This is the pool of the IPv6. Yeah? So, now we have an IPv6 full connectivity, but our client can't, our clients, if I see your client network property, your client, yes, your client did not have a IPv6 global IP addresses. Yes, this is just link local IP addresses. For deploying global IPv6 to your client site, you have two choices. The first choice is you require more IPv6 from HE. As I show in our slides, it's like here, like this. It's like this. Assign /48 more IPv6 address. Then where's my Russ? Yeah, Then your more IPv6 addresses is here. Actually, it's my prefix. Yeah, it's here. You can copy these IP addresses and you can use these IP addresses in our network, in your network. So my prefixes is these IP addresses. These IP addresses. So you can put this pool here directly, or you can put your pool, reference pool, in IP pool menu. Okay, we put your IP address here, and we click on the UI64, and we click on the advertise. I said this checkbox, this box enables the router advertisement package. So I enable these IP addresses. After that, if you look your IPv6 global IP addresses comes here. So you can Google it, IPv6, you can visit IPv6 websites, or you can create tunnel with another BGP service provider. For demo, I go to ipv6.google. Oh, it's Persian. ipv6.google.com. If this page is loaded, your configuration is true. Okay. Thank you for attention. If you have any question, I'm here. Okay, any question?
What about IPv6 DNS server?
Yeah, you can send other configuration for your clients. If you want to send the other option, we call this other option. You can send other options for your client in IPv6 settings. Actually, IPv6 DHCP client neighbors, IPv6 neighbors. In here, we just see IPv6 neighbor. This is our neighbors. If you want to send your other option for your clients, you can go to IPv6. IPv6 I think in DHCP server settings. No, it's not here. If I remember. Yeah. I know. You can send.
It looks like the DNS for IPv6.
Oh, okay. Okay. You can add DNS, IPv6 DNS in IP DNS field. You can add IPv6 DNS here. Yes, you can add IPv6 DNS here. Okay, but if you want to send this option to your client, you must enable other options in Slack auto configuration settings. I want to show this option for you, and yes, yeah. It's perfect. Yes, it's here. Yeah. Advertise DNS. You can enable this checkbox to advertise your DNS. Okay. Other question? Any question? I can't hear your son. If it is possible, take.
Not 6.4.
But.
Not 6.4.
Pardon me, I can't.
Go back to the slides, I'm sure.
Yeah.
List of the transition. No, transition slide.
Yeah, transition, yeah. Yeah, it's 6 to 4.
Not 6-4.
It's 16? 16.4? Not 6, not, yeah. Actually, Mikrotik can't support NAC 6.4, but you can configure on Cisco devices for transition NAC 6.4. I said because due lack of the time, I ignored the transition concepts.
I asked about experience.
Actually, we have this configuration in our Iran cell, the telecommunication network, telecommunication company. It's Iran cell. We have a NAC 6.4, but in a NAC 6.4 we have some problems, like VoIP problem. In a Skype, if you have a NAC 6.4 in your network, you can't run some application like Skype because there is a CGN or carrier grade net, and Skype cannot work with net. Yes?
And do you know it is implemented with Mikrotik?
You can implement it 6 in 4, 6 to 4, and actually DS Lite. You can implement it, this option, but you can visit in your wiki, Mikrotik wiki website, because Mikrotik develops our system router boards, and if supports every transition mechanism is announced in our website. Actually, we can have a dual stacks too. It's very easy. Actually, this transition like this, you have an IPv4 and IPv6 in simultaneously in your network, and we call this dual stack.
NAC 6.4 is needed if you want to give IPv6 to clients.
Yeah? This is the transition mechanism. I said, if you want to deploy your deploying IPv6 to your client side, you must do the transition mechanisms. I list all of the transition mechanisms here, but I say, if you want to more about this, you can inquiry our.
Mechanisms are commonly, but this is the pure NAC, so you are developing.
Actually, the using of transition mechanism is depend your network topology, and it's depend your users of how many users do you have. Yeah, for NAT 6.4, it's very helpful for carrier grade networks. I said, for example, mobile network. We do this transition in the mobile networks. But if you have another solutions, if you have a network comfortable with other transition mechanisms, you can use, for example, 6RD or 6 Rapid Development IPv6. Okay, any question? No question? Thank you.